Hello everyone, welcome back to the series where we are solving past 20 years of JEE Advanced questions. This question was asked in 2021 and it was multiple correct type. So one or more options could be the right. Okay, so let's try to solve this. This was given that a particle of mass 0.2 kg is initially at rest in the xy plane at point x equal to minus L, y equal to minus h, where L and h is 10 and 1 respectively. The particle is accelerated at time t equal to 0 with a constant acceleration 10 meter per second square along the positive x direction. Its angular momentum and torque with respect to origin in SI unit are represented by L and tau. Okay, I, J, K are the unit vectors along the positive x, y, z direction as usual. If K is I cross J, then which of the following statements are correct? Cool. So I can just draw the suppose this is our xy plane. Okay, and let's not draw z-axis. Okay, and initially particle was here. Okay, this is my x-axis, this is my y-axis, and z-axis is coming out of the screen. Okay, z-axis is coming out of the screen, so I am denoting it by dot. This was my initial particle position. Okay, and then particle was moving along the positive x direction. Okay, and acceleration was 10 meter per second square. So this was the initial conditions, and as per the option A, B, C, D, all of you guys can try to solve it by pausing the video, and once your attempt will be done, you guys can resume. So I am assuming like all of you guys have tried to attempt it. Let's start solving this. So the option A is given. The particle arrives at the point x equal to L, y equal to minus h. Initially it was at x equal to minus L, y equal to minus h. This point was minus 10, minus 1, right? Yeah. Now it has acceleration of 10 meter per second along the x-axis. So it will reach at this point x equal to L, which is 10 comma minus 1. This point is 10 comma minus 1. So what is the displacement? Total displacement in x direction is 20. 10 minus 10, which is 20. And how much time it will take? As we can use the second equation of motion. So 20 is equal to, initial velocity is 0 because it was at rest, half 10 t square, so it will turn out t equal to 2 seconds. Okay, so yeah, first option is correct. We can solve. Second option, torque equal to 2 nu. Okay, torque is 2 when the particle passes through the point. Torque was 2, this tau was torque, right? It's angular momentum and torque. Okay, through the point when the particle passes through the point x equal to L, y equal to minus h. Okay, at the same point, if we have to calculate torque, so for torque what we need? Torque is nothing but r cross f, right? So what is f? F is mass into acceleration. Mass is given, yes. So 0.2 into acceleration is 10 meter per second square in the right direction. Okay, so force is, we can say, force is mass into acceleration. Acceleration is 10 meter per second square and mass is 0.2. So I have rewrite force as mass into acceleration, which is 2. Force is 2 I cap. And what will be r? R is the distance from the origin. But what is torque? Torque is the for the torque we have to multiply the perpendicular components of position vector and force vector. Okay, so force is in the right direction, force is in the x direction. So the distance along the y axis will play the role for the torque. Okay, distance along x-axis will not play any role. So we just have to multiply the perpendicular component of the force. Okay, so force is in the I cap, so I have to calculate the distance in the j direction or y-axis. In the y direction, in the y-axis, force displacement is -1, okay, or displacement is 1. So torque will be force into distance, which is 2. Okay, so torque is 2k cap, which is right. Torque is 2k cap, which is right. Okay, let's see whether it should be -k or k. R cross F. R will be along -j, right? Why -j? Because the position was -1. So okay, right. So distance will be the direction of torque will be in the positive k direction. So option 2 is also correct. I hope everyone is clear. What I have done, force is in the x direction. So to calculate the torque, I have calculated the distance in the y direction. Why? Because torque is nothing but the cross product. In the cross product, we have to multiply the components in the perpendicular direction. Okay, so I have just simplified it, and 2 I cap into -j, which is 2k cap. Okay, so option B is also correct. Angular momentum is 4k cap when the particle passes through x equal to L, y equal to -h. What is angular momentum? Angular momentum is mr cross v. Okay, yeah. So what is r? R we know. What is velocity? Again, direction we should. Again, this thing will be same. Just instead of acceleration, we have to multiply the velocity, because what is angular momentum? Angular momentum is mr cross v. Previously, we have done r cross f, which is r cross ma. So we can calculate velocity here. What will be the velocity? Velocity will be v equal to u plus at. This acceleration is 10 meter per second square, and time was 2, so velocity will be 20, right? And initial velocity was 0, so of course velocity will be 20. So mass is 0.2. Again, velocity is again in the same direction of force, that is ik cap. So again, while calculating the angular momentum, I will take the perpendicular distance towards the velocity. So since a particle is moving in the x-axis, distance I will calculate in the y-axis, okay, which is 1, because y coordinate of y is -1. Again, velocity was 20, so this will turn out to be 4, right? So option C is also correct, option A was also correct, option B was also correct. Let's see option D. When torque is k cap and the particle passes through the point x equal to 0, y equal to -h. At this point, what will be the force? Force will remain same, because acceleration was same throughout the moment. So force will be the same, and perpendicular distance is also same. So torque will also remain same. So torque should be 2k cap, not k cap. So A, B, C is correct, and D is wrong. Okay. Throughout the motion, our torque will remain same. Okay, because acceleration is same, and perpendicular direction is also y-axis, like perpendicular direction to the x-axis is also same, which is 1 unit. Okay, because there is no movement along the y direction, there is no movement along the z direction. Particle was along the xy plane only, movement is only in the x direction. So throughout the motion, velocity, the cross product of velocity and distance, cross product of acceleration and distance will remain same. Angular momentum will keep changing because velocity is changing, but acceleration is same throughout the motion. So torque will remain same. So D is wrong, A, B, C is correct. So I hope everyone understood the solution. If you guys have any doubt, you can comment over here, and let's meet at the next video.